Hello everyone. So today I'm going to discuss a question regarding to my individual assignment. So without wasting our time, let us begin. As for the question, we need to discuss and sketch the following function of fx equal to cotangent x where x is greater or equal than 0 but less than or equal to 2 pi. So the first task is we need to find the x-intercept. So the most important thing for us to find x-intercept that we must make sure that fx must be equal to 0. So the question given is fx equal to cotangent x, where cotangent x is actually to be defined as cosine x divided by the sine of x. So cos x is equal to 0, hence x-intercept is pi over 2 and 3 pi over 2. So next we need to find the y-intercept. The tips to find y-intercept is x must be equal to 0. So we're going to replace 0 in the function and it will be cot 0. So we're going to refer back to our explanation earlier, which is cot x is equal to cos x divided by sine x. So it will be cot 0 divided by sine 0, and then we're going to get the answer, which is undefined. Hence, the y-intercept does not exist. So the third question, we need to find the open interval where the function is decreasing or increasing. We must follow step by step to know whether our function is decreasing or increasing. So the first step is we need to derive our function and we're going to get negative cosecant square x. The next step is we set the answer equal to 0 and then we'll know that x cannot be defined, hence fx does not have any stationary points. So next, we're going to substitute our x value, which are pi over 2 and 3 pi over 2 in the derived function, and both answers are the same, which are negative 1. So since both gradients are negative, hence the function is decreasing. So the fourth question, we need to find the x-coordinate of inflection point. To find the inflection point, we need to do the second derivative to the function and we're going to get negative 2 cosecant square cotangent x. Next, set the second derivative function equal to 0 and we're going to know that x is actually undefined. So hence, the x-coordinate at the inflection point at pi over 2 and 3 pi over 2. As for the fifth question, we need to find the vertical asymptote. As for the definition, vertical asymptote is a vertical line that guides the graph of the function. So for the solution, we must make sure the fx must be equal to cotangent x, where cotangent x is cos x divided by sine x. Next, when we do sine x is equal to 0, fx is undefined. So we're going to get x is equal to 0, pi, and 2 pi. So the vertical asymptote is at x equal to 0, x equal to pi, and x equal to 2 pi. Next, we're going to find the concavity. From the question, we need to find the open interval where the function is concave up and down. The first step is we make our interval based on the question given, which must be x greater or equal than 0 but less than or equal than 2 pi. So we can see the first interval we get the positive value and the graph is concave up. The second interval we have negative value, hence it concave down. The third interval we get positive value and it will concave up, and last but not least, the fourth interval we have negative value and the graph will concave down. So for the seventh question, we need to find the local maxima and local minima. So what is the local maxima and local minima? Since the function fx is equal to cotangent x does not have any critical points, so it does not have any local minima and maxima. The last step is we need to sketch the graph function. Since we have gathered lots of information, now this is the graph that we are waiting for. Thank you so much for watching, and this video was made by me, Dania Farisha Johari. My matrix number is 284281. I am from class B, and see you next time.